Hello friends, good morning. In my previous lecture, I had started with the techniques for measurement of high AC voltage. I had explained two techniques, number one by potential divider and second by using series resistance or impedance micro-ammeter, that is also called as series resistance or impedance milliammeter or voltmeter. Third method is by using series capacitance micro-ammeter. This can also be read as or named as series resistance, series capacitance milliammeter or series capacitance voltmeter. Only difference with respect to previous method is in place of having high resistance, we are having capacitance. Capacity reactance is given by 1 upon 2 pi Fc. F is constant, that is 50 Hz. So if capacitance is small, capacity reactance will be large. Capacity reactance will be large and current will be limited. So this capacitance is formed by number of capacitors connected in series and they are kept in a tube which is filled with oil. Filled with oil in order to cool, in order to provide the cooling. So here we are having capacitor. This is voltage V to be measured, that is high voltage, high AC voltage. Current flowing is I. This is micro-ammeter. This is protective gap to protect this micro-ammeter in case there is over voltage or this capacitor fails. Now this is the formula 1 upon 2 pi Fc. So V is equal to IXC. So I can be written as omega C into V. So omega is constant, that is 2 pi F. F is 50 Hz. Capacitance is also constant. So this is constant of proportionality. So this emitter can be calibrated in terms of the high voltage to be measured. Now let us see what are the advantages. First advantage is there is no resistance, so there is no active power loss. Second advantage, there is no resistance, so it is not causing any source loading. Third advantage, this capacitance does not change with temperature. Therefore, there is no error generated due to variation in the temperature. So all the drawbacks of previous method, that is series resistance micro-ammeter method, are eliminated. At the same time, when we are using resistance, it is actually acting as impedance for high AC voltage measurement. So that drawback is also eliminated in this method. But it has its own drawbacks. First is this method is costly because capacitors are relatively costly than the resistors. And second, most important drawback or source of error, cheap source of error is if this voltage contains harmonics, then this generates error in measurement. Now let us see how the harmonics affect the measurement. Now if harmonics are present, now if harmonics are not present, this is the formula. I is equal to omega CV. Omega is 2 pi. So let us say it is omega 1 CV. Omega 1 is omega 1 corresponds to the fundamental frequency, that is 50 Hz. Now harmonics are present. This voltage is given by V1 square plus V2 square up to Vn square complete square root, where this represents fundamental component of the voltage, second harmonic, third harmonic and nth harmonic. So voltage is obtained by this equation. So obviously we can find the corresponding current also. So let us say I dash is the current which is measured due to presence of harmonics. So formula is omega CV. C is constant, so we can take out this common. So V1 will be replaced by omega 1 V1 square plus omega 2 V2 square up to omega n Vn square complete square root. Now here omega 1 corresponds to 50 Hz. Omega 2 corresponds to second harmonic, that is 100 Hz. Third harmonic 150 Hz. So omega 2 can be written as 2 times omega 1 because it is 100. This is 50, it is 100. So this can be written as 2 times omega 1. Similarly, if third harmonic is there, it can be written as 3 times omega 1. So we can take out omega 1 also outside this bracket. So it is C omega 1. Here we have taken out omega 1 common. So V1 square plus it was 2 into V2. So 4 V2 square. Next term is third harmonic. So 3 into V3 square. So it is 9 V3 square up to n square Vn square complete square root. So in this way we can compute I dash when harmonics are present. So if you compare these two equations, obviously I dash will be greater than I. So actually current measured is I dash and not I. And we want only the fundamental component. So there will be error in measurement. Voltage measured by this meter we show higher value than the, because fundamental component is there as well as harmonics are there. So this meter will indicate the voltage which consists of fundamental plus harmonics. We cannot extract only the fundamental component in this method. So this is the chief source of error when the voltage contains harmonics. Now I will explain this by a numerical. Numerical. A series capacitor micro-ammeter is to be designed to measure high AC voltage. Micro-ammeter can measure minimum 3 microampere current. If minimum voltage to be measured is 30 kV, compute the capacitance required, and maximum voltage it can measure if upper range of microammeter is 100 microamperes. Compute the error generated in measurement if voltage waveform contains 5% fifth harmonic. So in the first part we have to design a series capacitor microammeter. The microammeter has can measure minimum 3 microampere current and maximum 100 microampere current. Minimum voltage to be measured is 30 kV. Now we have this formula, I is equal to omega CV, that is 2 pi f C into V. Assuming 50 Hertz frequency, the minimum current, and assuming the minimum current which can be measured by microammeter corresponds to minimum voltage which can be measured. So using this formula we have I omega CV. Omega will be 2 pi f. So 2 pi into 50. I is minimum current, that is 3 microamperes. So this is 3 microamperes, and this is V. Minimum voltage to be measured 30 into 10 to the power 3, that is 30 kV. So here we are using this formula, C will be equal to I upon omega C. So I is 3 microamperes, omega is 2 pi f, and V minimum is 30 kV. So after solving we get capacitance required will be 0.32 picofarad. So we have to design the capacitance of 0.32 picofarad in order to measure the 30 kV voltage corresponding to 3 microampere current. Now assuming upper range of the meter corresponds to maximum voltage which can be generated. Now maximum voltage which can be generated we have to find, which can be measured we have to find. So let us assume that maximum voltage which can be measured correspond to the maximum or upper range of this meter. Upper range of this meter is 100 microamperes. So 100 microamperes will be 2 pi f into C multiplied by V. So V corresponds to 1000 kV. So if we are having a capacitance of 0.32 picofarad corresponding to frequency of 50 Hertz, then with a microammeter which can measure minimum 3 microampere current and maximum 100 microampere current, we can measure minimum 30 kV and maximum 1000 kV. Now second part of the problem is we have to find the error generated in measurement if the voltage contains 5% of fifth harmonic. So with harmonics we have derived the formula. So it is I dash W into C V1 square root of V1 square plus 25 into V5 square. 25 because it is 5%. So 0.05 to the power, it is, I'm sorry, this is 5%. So 5% is square of this 25. Just wait. I dash is omega C, omega into C square root of V1 square plus it is fifth harmonic, so square of 5 into V5 square. So this is the correct explanation. I dash is W, that is omega into capacitance complete square root of V1 square plus it is fifth harmonic, so 5 square into fifth harmonic voltage square. So omega 2 pi f, C we have computed, that is 0.32 picofarad, V1 in bracket 1 plus 25 and it is 5%, so 0.05 square So it is coming 1.03 omega C V1. So V1 can take any value from 30 kV to 1000 kV. But measured voltage will be 1.03 times whatever is the fundamental component. So if only fundamental component is present, this will be omega C V1. But if fifth harmonic is present with 5%, then current measured will be 1.03 omega C into V1. So there will be error of 1.03%, means current measured is higher than 3%. It will be higher than 3%. Okay. Next time I will explain the peak reading voltmeter. Friends, if you feel this video lecture useful, then please like it. Subscribe to my channel. Ask your friends, your colleagues, your juniors to subscribe to my channel for upcoming video lectures on high voltage engineering and power system protection. If you want to make effective and efficient use of time, then read my book on time management. The link for the book is given in the description box. I have launched a useful course for the students on Udemy. This course is very useful for the students who are preparing for entrance and competitive exams. The link for the book is also given in the description box. Thank you.